All right, so we're starting a new chapter now, so we're chapter 5. And we're going to fill in that flow chart that I started before. We're going to get the rest of that. So leave a lot of, like, write small for this. I'm going to do matter at the top. And as you know, matter is broken up into 2 categories. We have pure substances. Pure substances are either elements or compounds. And then compounds, of course, can be broken up into either ionic or covalent. And all this stuff on the left side of this chart, we've already studied, right? Chapter 3, we did the periodic table, and that was all the elements. Chapter 4, we talked about ionic and covalent compounds. So we're done with all that. So now we're going to talk about substances that are not pure. And so you might guess if it's not pure, that means it's a mixture. It's made up of more than one thing. So we classify mixtures basically by how well dissolved things are, or how small the particles are in the mixture. So there's 2 main categories. One is homogeneous, and the other is heterogeneous. And I'll define these all after I'm done with this chart, but basically homogeneous means it all looks the same. If I take out a sample and you take out a sample, they're going to be identical. Whereas heterogeneous means every sample could be different. So a homogeneous solution could be like a cup of salt water or a cup of tea, right? You scoop out one scoop and I scoop out a different scoop, they're going to be the same. Whereas a heterogeneous mixture could be like a cup of soup. I might scoop out a carrot, you might scoop out a noodle. There's different things in there. So not every sample is going to be the same. That's heterogeneous. Homogeneous, broken up into 1 category only. It's called solutions. They're the only ones we talk about anyway. For this class, basically solutions are things dissolved in water. Salt water, sugar water, any kind of solution, anything like that. Heterogeneous has 3 different categories. First, they're called colloids. Similar to solutions with a little bit bigger particles, you can separate them easier. Suspensions. And finally, emulsions. And these 4 types of mixtures are the ones that I'm going to show you today. Start erasing?
Yes, please.
Okay.
That's the M.
Where? Emulsions, yeah, that's it.
Can you just leave up on the header?
Okay. All right, so first let's define homogeneous. Okay, so this is just a mixture that is the same throughout. So, some examples. Like I said, salt water. Or tea, coffee. It doesn't have to be a liquid mixture. You could have a mixture of metals, like an alloy. If you're looking at like stainless steel or bronze or brass, it looks the same. Each piece of metal is the same. The metals are completely mixed. Right? So anytime you have a mixture where it looks the same throughout, there's two things in there, but they're completely mixed together. More than two times per week, several things. So for solution, which is the type of the only type of homogeneous mixture we're going to talk about, we're going to say mixture where one substance is dissolved into a liquid. And again, this isn't the perfect book definition, but this is the definition that makes sense for what we do in this class, because that's basically what you see for solutions are stuff dissolved in water, which is a lot of what we use in chemistry, is chemicals dissolved in water. All right, so that's it for homogeneous. Heterogeneous. So this, of course, is going to be the opposite of what I put for homogeneous. So it's going to be a mixture that is not the same throughout. Okay, so here we're going to have, let's say, chicken soup. Soil, right? Soil will be dirt, but also twigs, rocks, leaves, all mixed together. Right? So I might pull out a twig, you might pull out a stone. Not every sample is the same. What else do I have? Orange juice with pulp. Salad. Basically, you should be thinking of any mixture where you can see more than one color or where you can pick out different things. That's a heterogeneous mixture. All right, so first type are called colloids. And this is really the hardest one for me to explain to you because colloids have really, really small particles and they almost look like solutions. So they almost seem like they're homogeneous, but they're not. And the reason is that the particles are a little bit larger, and so it's easier to separate them than you would be with a homogeneous solution. So I'm going to give you this. I'm going to say it's like a solution, but particles, the things that are dissolved into the water, are slightly larger. And I'll show you here. So like, this is a solution. This is salt water, right? So if you take a scoop out, and I take a scoop out, it's going to have exactly the same concentration, right? The salt is evenly distributed throughout the water. This is milk mixed in water, and the difference is that if you were to look at the particles under a microscope, the particles of milk are much, much larger. And that's not usually how we tell if something's a colloid or solution. What we usually do, and I was supposed to do this, but I don't have it because, well, it's my fault. Anyway, you usually shoot like a light or a laser through these things, and you'll see with a solution it'll go straight through, but with a colloid it'll bend. And if I get one tomorrow, I'll show that to you. My friend was supposed to bring one in, and then left me to dry. Anyway, so that's the difference between those. So colloids usually look like solutions, but the particles dissolved are a lot bigger. And then we have suspension. And so here the particles are going to be even larger, big enough that you can see them or strain them out with a strainer. we're going to say large particles they will settle over time. So this means if something's a suspension, if you leave it sitting for a day or a couple days, the whatever's dissolved into the liquid will fall to the bottom over time. And so then you have to shake it before you can use it. So if you have orange juice with pulp, right, and I dissolve, mix some into water, you can see those little pieces in here. You have to stir it up to get the pieces back mixed in. Otherwise the pieces sit at the bottom. So anything that you read and it says shake before using, medicines, antibiotics, stuff like that, if you have to shake it, that means it's a suspension. We'll say OJ with pulp, some medicines. Those naked juices, right, they all have little pieces of stuff in them. You gotta shake them, otherwise the stuff goes to the bottom. So anything that you have to shake before you use, usually gonna be a suspension. Okay, this last category is a little bit strange. I'm going to write this definition and I'll explain it. So, a mixture of two things that do not mix. So, for example, water and oil or vinegar and oil. The two things that don't mix, being made to mix, with an emulsifier. Okay, so the emulsifier is like a third ingredient that you put in that makes the first two mix. So you have two things that shouldn't mix. When you put this other thing in, it makes them mix together. For example, oil and water don't mix, but if you put soap in there, soap makes oil mix with water. That's why soap will wash oil off your body, but just water by itself won't, because the oil won't dissolve in the water, but if there's soap, it will dissolve in the water. I'll show you another example here. We're going to do vinegar and oil. So if I take some vinegar here, and I pour it in here, and I put some oil, and I'm sure you've seen this before. These two will separate. And you can see the vinegar is the bottom, the oil's at the top. And I can stir this for all day, and it's going to separate again. The oil's going to go back to the top, the vinegar's going to go back to the bottom. There's nothing I can do to mix these. I can put it in a blender for a half hour, and they'll separate again. But there is an emulsifier that will mix these, and that is egg whites. And does anybody know what this makes if you mix these three things together? You've eaten it before.
Nasty eggs.
Mayonnaise.
Huh?
Mayonnaise.
Mayonnaise, yes, you had that last year. It makes mayonnaise. So you just take an egg. You actually only need the egg white, but you can throw the whole thing in there if you want. And you mix it around. Huh?
I was waiting for Rochelle to get it wrong.
That would have been.
That's really what to turn into mayonnaise.
Yes, this is what mayonnaise is made out of. Now, when you make it, and you can see they mix together, right, the oil and the vinegar. But you got to stir it for a long time to whip it up and make it get that thick consistency of mayonnaise. But anyway, they've already mixed there. You can see, and if you stir it for a while, it'll start to look more like
Can I
mayonnaise.
keep making it mayonnaise?
Yeah, here you go. Just don't make a mess. All right. Questions on any of this? All right,
That's
good.
all the notes.
That's it. Somebody with clean hands, pass these out.
Ooh, I don't know.
All right. Oh, Abe's gonna stand up for a minute. Michael needs to stand on that desk.
Michael? All right.
That's what he does every day. I don't know.